Hello, my name is Bob Vrabel. I'm here representing TAE Aerospace on behalf of TAE Aerospace. And I'd like to thank all of you for stopping in to watch this session. I'd also like to thank Concord Batteries for allowing TAE to have the opportunity to participate in this event. I'd like to tell you a little bit about TAE before we begin. The subject matter that I've chosen for this is basically some technique oriented servicing items on the TPE 331 family of engines. Now, TAE Aerospace is a global company with interests in both defense and aerospace, both fixed wing and as well as rotary wing as well. If you're interested in seeing TAE's capabilities, by all means, please refer to our website, TAE, www.taeaerospace.com. And you'll be able to then scroll through the web or wander through the web and see some of our capabilities. This is especially true when it comes to the 331 family of engines. Now, I'm based out of the headquarters in Scottsdale, Arizona, the American headquarters in Scottsdale, Arizona. And our primary focus there is the major engine inspection repair of the TPE 331 family of engines. But in addition, we also provide as a service a complete LRU main repair and overhaul capability of doing manufacturing style repairs on engine components as well. The ability to come out to the field, out to your location. So if you do operate or maintain 331 engines, we do have the ability to come out and field repair. We also offer parts, sales, and service, as well as a 24/7 customer support organization. And part of that also is technical training. If you're interested in finding out more about the capabilities or would like a quote or something of that nature for any type of work on a TPE 331, I highly recommend you go on to the TAE Aerospace, and up in the upper right-hand corner, there's a Contact Us tab. By clicking on that, you will get the spread out of all the different locations, as well as the names of all of our worldwide sales force that you can contact directly, and they would be more than happy to discuss your needs and how TAE would be able to support that. Now, again, my name is Bob Vrabel, and my primary job with TAE is I coordinate all of the training involved with the TPE 331, and I'm also the primary instructor. There you see my contact information. If you're interested in obtaining information, costs, availability, scheduling, as well as a syllabus of what we do offer. TAE is the only training facility in the world that trains on the TPE 331, in which we are able to do so with engine aircraft specific training. Our training is targeted to only the aircraft that you're dealing with. We do have a generic line maintenance course. All of our courses are certified by the FAA for IA renewal. We also have had spot approvals from CAA New Zealand, and we are currently in the works trying to get approvals from Air Transport Canada, as well as CASA in Australia for approval of our courses in lieu of testing and licensing. Again, I work out of the Scottsdale facility, which is located north of Phoenix at Scottsdale Air Park. And there's the address and the phone number to our main lobby area. And so if you're interested in calling and finding out more about our capabilities, please, by all means, do so. And we'd be more than happy to help you out in doing something along those lines. Now, as I said, what we're going to be trying to have a discussion on is some specific servicing items, not every possible servicing item within the time frame that we have. There are a couple of them that I've found that in my training courses, there has been some misunderstandings or a general complaint from all the technicians that hey, we've always had problems with this, or hey, this is giving us problems, and we'd love to know a few tips or tricks or something along those lines. For the servicing of the engine, some of this servicing is going to be contained as your scheduled inspections, and so the two primary places you're going to find your scheduled inspections on the earlier model engines, usually the -8 and earlier down to the pre-century, so the prior to the -10 engines. the information is still contained in the maintenance manual forward section, the engine general section, 720000, inspection and check, and you're going to refer to the scheduled maintenance matrix that's there. On the Dash 10 and 11 engines, as well as the Dash 12 engines, this information, if you refer to the maintenance manual, it's probably obsolete. That the scheduled maintenances, as well as some of the inspections and servicing, has changed so rapidly that what Honeywell elected to do was to absorb that information into the original service bulletins for the Dash 10 and 11 and the Dash 12 engines. You see them there, 720180 and 720476, which were the original bulletins that established your life limited parts and bearing reclamation cycles, your major periodic inspections. Well, now there's a section that incorporates the scheduled inspection. So do not refer to the particular section in the engine maintenance manual. Utilize these two bulletins. They are more current than your maintenance manuals. And so this was done because these were easier to update and to globally distribute as well. Now you can also refer to, for some servicing items up in the front matter of the maintenance manual as well, 720000 servicing. You're going to find that this section is heavily loaded more towards lubrication change, your oil, servicing your oil level, and then also the main oil change interval, or how to change oil, different types, etc. Beyond that, what you should be doing is also referring, if it's a specific filter or a specific item of servicing, refer to the applicable engine maintenance manual chapter section subject, which is typically identified in the scheduled maintenance matrix. So it would refer you out to a specific chapter section subject to then remove, replace, clean, inspect, and do all of that information in the specific chapter that applies, or specific subject that applies to that particular item. Now, looking at the engine, I'm going to confine my discussion to the small block engines. So this will be the pre-century up through the Dash 12 engines. The Dash 14 would be similar in scope, slightly different in the scheduled intervals and everything, but there are going to be a few differences. I have pictured here specifically one of the last engines we still have in production. That's the Dash 12 JR. But and it is an inlet down. There are some slight differences with the inlet up engines, the fact that there is no oil tank. But we will be having a brief discussion on many of the different servicing items, specifically the temperature compensator. I'd like to have a brief discussion and try to guide you a little bit on the three basic ways, I call them good, better, and best, to set up a temperature compensator, because there is now a scheduled servicing, a scheduled interval every 150 or 200 hours that you're having to go in there and verify the function and operation of the compensator. Now, on this side of the engine, we see there are going to be a lot of items for servicing. Of course, your oil level at the oil tank, whether it's engine provided or airframe provided, that's irrelevant. We'll be talking about your servicing, what happens when you get a filter bypass event. If we go back, we can also talk about what happens if we get it over here on the front of the nose cone. If we get a chip detector event, that would be another item. There are also going to be, of course, your main oil filter, your main fuel filter. We're also going to have some filters in, if you are equipped with a limiter bypass valve or a torque or temperature limiting system, there will be an inlet filter into the valve there. We are going to have a brief discussion on some items related to the igniter plugs as well, that the servicing and the checking of the igniter plugs. There's some clarification, some things technicians have been making a mistake when doing the inspection, and I'd like to do some clearing up of that. We don't see down in the bottom here, you also have your flow divider filter. We'll have a discussion on that as well. So without further ado, if we'll just go ahead and we'll just jump right into it. Now, of course, probably one of the most common items you folks are doing is going to be changing the oil filter. If it's not for an on-condition event caused by either a chip event or an oil filter bypass event, this is typically done through 720000 unscheduled inspections for your oil system contamination. Excuse me. But under normal circumstances, small block oil filters are being changed as part of the spectrometric oil analysis program, which is going to be between 100 to 200 hours, depending upon your phase. The filter, again, is a 10 micron cartridge type replaceable only element. And the organization that you see here in this picture would be the latest and greatest service bulletin compliance. The angled adapter with the retainer, a one-piece cap, and then, of course, the centering spring, which retains and aligns the filter in the cap. One of the bigger issues we tend to have is this little statement over here, hand tighten. We try to discourage the technicians from using a wrench. At the back end of the filter bowl, there is a wrenching flat. We try to discourage technicians from using a wrench because with hand pressure, you should be able, even on some of the worst horse collar installations, you still should be able to run this down to cinch without having to use a wrench. Maybe if you needed to basically give it a bit of a snug, that would be okay. But what we're concerned about is that wrench tightening this thing right from the jump. You may or may not have the filter aligned with the nipple fitting here. Now on the one piece arrangements, as you see here, this is less likely. But if we go to the older two-piece style cap, the older, even though I may have an angle adapter, the old two-piece style cap did not have the clip in it. And when you put the filter in and tipped it sideways, it fell out of alignment. And so running this thing down with a wrench, regardless of whether it's a strap wrench or a spanner wrench or whatever, if it was misaligned, you're crushing the filter. And as a fiberglass cleat with a nylon mesh, then basically that filter would basically destroy itself and then contaminate your entire lubrication system, which would include if you have a hydraulic torque system, and obviously your propeller control system utilizes the same oil. So we try to discourage the wrench tightening. One item that you may be aware of, for those of you that are in the know, that with a two-piece cap, it's not bad to go ahead and install the oil filter on first, then bring the bowl in behind it. So that tends to work a little bit better. So we try not to drop it in the cup, put it on there, and then hopefully, as I'm screwing it down, I wind up getting it lined up. So that's one item also. Another item that I've been asked to talk about with the technicians also, I guess is and don't shoot the messenger. Something about the filters not being juicy enough, I guess. So what's happening is that the belief is that when you're doing your soap samples, you're taking the filter out, putting it into the jar, and then disposing of any liquid that remains in the bowl and everything. They'd like you to please pour that into the jug with it, because depending upon your installation, we tend to see this more on low wing aircraft, so like the Fairchilds, etc. That when the engine's shut down, oil kind of backflows a little bit away back toward the tank through the system, and this has had a tendency to maybe push material off the filter pleat and into the surrounding liquid of the bowl, and so it's not being caught when they're doing the analyzation of the filter weight, the filter paper itself, etc. So please be sure that whatever liquid is in the bowl, please include that with your oil filter. All right. Now your oil filter bypass valve, the two basic styles, I'm showing you the newer style here. The newer style incorporates the pop-up incorporates an impending bypass, whereas the old filter bypass, which was easily identified, it was yellow in color, usually with a little tiny red pop-up indicator, did not have an impending feature. That when the pin was extended and when you did your pre or post-op inspection, if you had the old style, you had a bypass. So the filter was basically bypassed. With the new style filter, the pop-up indicator will extend actually before the bypass feature kicks in. For those that would be interested, it's about 30 to 40 PSI of differential. You get the pop-up. If differential continues to rise and reaches 50 to 60 PSI, the same as it was on the old valve, you get full bypass at that point. Another unique feature of this, or what had happened is that technicians were basically attributing all pop-outs of this to had to have been cold oil, And the reason for that was because the old pop-out, the old bypass valve did not incorporate a thermal lockout feature. And what had happened is that cold, thick oil, even through a perfectly clean filter, can generate the necessary differential and extend the pin. Well, it kind of developed a malaise in the community where it's just a cold oil, and they kept resetting it, not realizing they may have had catastrophic wear. Well, this new feature on here is that if your oil temperature is less than 38 degrees Celsius, inside the pin area, there is a bimetallic set of wafers that will warp and bind the pin if your oil temperature is less than 38 degrees Celsius. So even if you did get a cold, thick oil differential through a perfectly clean filter, you would not get the pop-up indicator. So now once your oil is above 38 degrees Celsius, normal oil temperature is 55 to 110 degrees Celsius, that the filter pop-up will then operate normally. So on the newer style, if you get a pop-up indicator, it is a real indication that you have had a filter approaching a bypass condition, and it should be investigated as a serious event. 720000, inspection check, unscheduled inspections, oil system contamination. Now, another item for checking, both as a on condition event as well as a scheduled interval, is your chip detector. Now, not all aircraft is the chip detector physically wired, so you may or may not get a chip light, but there's still going to be an inspection interval where you will have to remove it and inspect it visually. Those that don't have a chip light typically also have a continuity check first, to make sure basically that if they see continuity, they pull out the detector and there's nothing on it, then they understand that there's something wrong with the chip detector. Or if they see no continuity, they still pull the chip detector out, and now you have a piece of material on there, then that would also be a problem with the chip detector as well. Biggest issue probably what we're having is over torquing of the housings, believe it or not, that on some of the engine models, or not on some of the engine models, but before there was a repair for this, the chip detector housing, that self-closing valve, actually threaded into the magnesium of the gearbox. And over torquing was actually stripping out the magnesium. It was damaging the magnesium. And contrary to popular belief, double bubble epoxy or JB Weld is not an authorized repair scheme when you strip out the threads. Typically, it's repaired by having a shop like TAE, who has this capability to basically over tap that and put in a steel insert. Well, that doesn't seem to have stopped some of the folks because they're still over torquing them, but now they're shearing off the head of the self-closing valve, and you know, the back portion of it falls into the gearbox. So it's not good either way around. Another item that we also want to caution you guys on is the chip detector housing has a lock wire location. On inlet down engines, it is located here in the bottom of the nose cone. On inlet up engines, it's located on the opposite side of the accessory gearbox housing. In both locations, there is a lock wire location. Now, this is in the magnesium, or if you happen to have an aluminum nose cone, this is the location that you would tie to for that chip detector. What we're seeing is people are using the roll and snap method of breaking the lock wire and are unfortunately canoeing out this particular area. Okay, and with nothing else to lock wire to, the choice is being made to just simply not lock wire. And in which case there have been events to where the housing has rotated through vibration, has rotated out of the gearbox and nose cone, and you now have an engine in-flight shutdown for a loss of oil. So just be aware of that. Pay attention to the torque when you're putting the housing in. Should you be using it as a drain plug to drain oil out when you're doing an oil change? But also do not use the roll and snap method to break the lock wire that's holding it in place. Now, so that would be our oil system servicing items. So, so the filter, as well as the oil filter bypass, and then the chip detector as well. Now, in the fuel system, we're going to have a series of filters. One of those is the main fuel filter, located on the 400 series style pumps. It's actually pointing, you know, it's incorporated more vertically. on the 399 pump that you would have on, say, the Casas, some of the Caravans, things like this. It has, you saw the more angled down, if you guys don't mind me making you dizzy a little bit here. You can see that on the 399 series pump, the fuel filter is more angled down, as you see it here. This filter does not give quite the problems that we have been seeing with the 400 series pump, and it usually comes in the condition of a galled set of threads, because technically they only want you to use fuel, like the fluid going through it, to lubricate the threads. It's been found that fuel, while it does have some lubricity to it, it's more of a better solvent than it is a lubricant. And so the potential for galling is, if you don't get that cap on just right, being able to cross thread it fairly quickly or gall it in a portion of it if the threads just aren't pretty. One recommendation would be to use engine oil. Engine oil, basically, the amount of oil you will be putting on there is not going to cause any kind of major fuel contamination in your fuel system. Another item that has been happening is it's hanging up, that the fuel bowl, the filter itself, is in a bowl with a couple of clips on it. And those clips over time will get loose and will wobble around. And so one item that you can do that is, and use it sparingly if you're looking for a way to assist yourself with this, look for it sparingly, is a small amount of Aeroshell 5 on those clips. Just a small little amount up on the bowl section will basically stick them up into place, allowing you to bring that bowl down. And it does not cause any adverse effects on the fuel system. So, but again, make sure that when you are putting the bowl on, that it is square. It's just so very easy to tip it ever so slightly, and so caution should be done to make sure the bowl, or the bowl top, is square as you begin, and to slowly. You should be able to, the majority of the way, get this down by hand. If you feel the need to put a wrench up, if you've just barely started and you feel the need that you've got to put a wrench up on the flats here, you're probably about to have a galling event. And so you should be able to get it reasonably down pretty far with just your hands. Now, another filter you guys will be servicing is your flow divider filter. This is located in the inlet fitting of the flow divider, right up in the sleeve here. It's a spring-loaded self-bypassing screen. Typically every 400 hours, you guys are taking these out and cleaning them. Replacement, I mean, ultrasonic is usually the method. If you're interested in finding what all the different methods are for this, if you refer to 72-00-00 cleaning, that is all the methods of cleaning. The cleaning method issued you will find under the chapter section subject for the disassembly of the flow divider. That in the cleaning page block, it will give you a method, a recommended method for cleaning this particular filter as well. Now, for those that are for those of you that have TPE 331s that incorporate a temp or torque and temperature limiter bypass system, then you will have a valve like this. The location will vary from engine model to engine model, but the design of the valve is fairly consistent. And at the inlet of the valve, right here, incorporated into the fitting, is a 70 micron inline filter. And so that also at 400 hours will be removed by you and then cleaned in accordance with the chapter section subject recommendations for the cleaning page block for the bypass valve itself. There isn't a whole lot to say about that. A lot of people don't realize it's a filter or its physical location, and so are kind of surprised that there actually is an inline filter at that particular location. Now, when it comes to servicing of the ignition system, several different items here with the ignition system as well. The plugs themselves, of course, we always try to caution people that do not handle the system shortly after operation, as there could be a residual charge still left in the capacitor inside the ignition unit. And if you get on the wrong side of that, it will hurt you terribly. And so when handling the system, we recommend waiting approximately 5 minutes that in the units themselves is a bleed down resistor designed to dissipate most of the charge off of the ignition system. When you handle it, still give it the respect it's due. Whenever you ground out the system, most common method, military used to have grounding probes. Most of the commercial operators use a flat tip screwdriver touched onto the end of either the lead that's been pulled off the end of the igniter plug before you pull it out, or if the igniter plug was out with it, then at the electrode, the center electrode here, and then touching that to some thick, beefy portion of the engine. One of the problems we have is we're getting people touching it to sheet metal. And when they touch it to sheet metal, if it does have any residual charge, even still, it can arc and tack weld, and now you get a weak spot in your sheet metal that over time could physically erode into, like a cancer, could erode through the sidewall of your combustion chamber case or your compressor housing, this type of thing. So try to avoid touching sheet metal and go more towards the beefier portion, bracketry, or the thick flanges of the compressor housing also make it very nice. Now, this is an excerpt taken directly out of the maintenance manual for the inspection of the igniter plugs, and I want to talk a little bit about this. The two primary things that are being checked, other than obvious damage, and they give you examples down here. Any damage to any of the ceramic insulator, anything that looks like loss of material caused by flame contact, etc. The one thing this picture doesn't address also is the depth of the groove that usually occurs right down about in this area from the grommet that the igniter plug fits into, that over time there's a vibration. And basically at its deepest point, you're allowed 31 thousandths of depth. And I'll leave it up to you as to how you want to do this. One method that has been put out would be to use like a piece of 32 thou lock wire, lay it in the groove at its deepest point, and see if you can, either with a stylus or a pick or something, see if you still bump over it. Typically, then that would tell you, if you actually dip in with the lock wire in that location, chances are you're well over your 31 thousandths of depth. And so that's one way of doing it. Beyond that, vernier caliper, being able to go from parent material to the depth at the greatest point is also another good method. Now, what you're primarily looking, of course, with an air gap igniter plug, you're getting spark in basically 360 degrees, and as it sparks, material is in small amounts is being removed, and so you're measuring basically the cathode crater, if you will, at its most extensive. And so then you can see there's a limit right there. I don't know if you guys can read that very well. It's 330 thousandths of an inch maximum at its maximum width, even at one location at its maximum width. That's enough to reject the igniter plug. The other is as it sparks, your center electrode will erode down in. Now, what we're worried about is that if I get more than 330 thousandths of crater on the cathode, or if my electrode erodes more than 90 thousandths down in, now I have too much gap to be able to span, and so the spark will not occur. And so that's our primary concern. Now, one of the big problems that we tend to see with this is that when measuring that electrode depth, okay, a lot of people don't look at this. Center electrode shall not exceed 90 thousandths of an inch below the end of the ceramic. What we tend to get here is that guys will measure from the end of the igniter down to the electrode. This is not what you want to be doing. I don't even think a new, brand new spark plug, a new igniter plug would actually pass this particular check. So what we're talking about is where the ceramic is, which is typically, my drawing may not be exactly right, great, but where the ceramic you see over here on the outside with the center electrode in blue, basically what you want to measure is from that location down to the electrode. That would be the more correct way of doing so. And so whatever method you use, do not use as your reference from the end of the igniter plug, get down to where the ceramic is. So that would be one item. Now, another item we talk about, and there is some concern, and there has been some concern because there have been some incidents. of galling, as well as also a galvanic plating, is that what is the correct anti-seize compound to use where the igniter threads into the combustor plenum. The procedures in the igniter plug section, chapter 74, call out C5, the copper, but there is a big note that says Phillips milk of magnesia, which is the more desirable. What's happening is at least, especially with TAE and with Honeywell, is that the compound is no longer C5. The preferred compound is Phillips milk of magnesia, and you heard right, the laxative is used, and primarily because of the similar materials to what the combustor plenum is manufactured from. Because when you lather on the C5 and you thread it into the material of the boss of the combustor plenum, you actually have two dissimilar metals joined together. And when that junction is heated, you have a thermocouple. Basically, an electrochemical reaction will take place, and it can and if it's bad enough, if there's and combine this with operating in a heavy marine environment, you now have a catalyst just from the air and everything else. It tends to overemphasize this to the point where it has virtually plated or welded, I guess, the igniter plug into the boss itself. So bad in some cases to where there's been damage to either the combustion chamber or to the igniter plug just trying to get it out. And in some cases it was not able to come out without basically being damaged. So Phillips milk of magnesia is a more compatible compound with the as a barrier between the igniter plug and the combustion chamber case boss. There has also been a push afield to also go Loctite makes a magnesium-based paste. One of the problems with the Phillips milk of magnesia in a lot of cases is that it's very thin and runny, and so galling or whatnot. But if you look at the top of our compounds list, it basically says acceptable substitutes may be used. And what you have here, if you're interested, is and I've used this on other gas turbines, not just the TPE 331 that I do training on. It's becoming the approved compound. That it's Loctite high temp white. It's more of a paste. It's a magnesium-based paste, so it's a metal-free paste. It's a magnesium-based paste that, like Phillips milk of magnesia, provides a more compatible anti-seize compound that does not then turn around and have the effects of a thermocouple or electroplating. So that's something that you may want to look into. Here again, as I said, Phillips milk of magnesia is called out as an alternative, but if you go talk to almost everybody at TAE and places and other shops that I've been around, that it is the preferred, not the alternative. So hopefully do yourself a favor and not have to worry about having a igniter plug seize up on you. Now we start getting into the air system. In the purge system, you do also have a 300 micron inline filter, which is going to try to filter out as much of the particulate coming out of the compressor airflow that would be flowing into your purge system. Here again, this is right around 400 hours. Big thing to remember with this is that the filter itself is unidirectional, that on one of the wrenching flats up here, there is an arrow that must point in the direction toward the accumulator, the storage accumulator. So whether all of this material is mounted on the engine itself, or it comes with the engine assembly, or is supplied and then mounted in the location by the aircraft manufacturer, regardless of that, that filter has got to be pointing at the storage accumulator to allow the air to freely flow in. Failure of having that thing turned around, the system will not charge. You will not get the momentary rise in RPM. You will not get the momentary rev in EGT or hear the engine rev up, which and generally when I get a complaint on phone by this, my first question is always, have you done any phase maintenance? And if they say yes, I usually say, you may want to go out and take a look at that filter. I think you might have put it in backwards. So that is about the only thing. Other than that, it's a standard flush filter, again, ultrasonic or a solvent flush, and then blow an air dry, that type of thing. So it isn't a big evolution to be able to go and clean that filter. Now, the other item we were talking about where we have some technique involved is your plenum drain valves, that at the 6 o'clock position on the bottom of your combustors, you're going to have 2 plenum drain valves. Now, these are air-operated valves, takes about 3 to 5 psi of P3 pressure to close. So they're a normally open valve. And again, the purpose was back in the day that when you shut the engine down, before the purge anyway, was that any liquid that remained at the 6 o'clock position would then be directed to an aircraft overboard drain. With the advent of the purge, that should not be the norm any longer. But should you ever have an aborted engine start or have to shut the engine down in an emergency, most emergency handles, most of your stop and feather controls do not have an input into the purge solenoid. It's basically a manual override of the fuel. So what happens in a lot of cases is that the accumulated fuel is still going to drain by gravity. Well, we can't let it sit there. And so that's the job of the plenum drain valves. Now, they've added an additional task now that you guys have got. Basically, starting at 300 hours, there's going to be an installed check in which you will take air, leaving the valves installed, not removing them, leaving the valves installed. You're going to apply air pressure at the outlet fittings, right here where I'm showing you here, listening for the air to be hissing up inside the combustion chamber. Then at 900 hours, these valves, at 800 hours, apologize. At 800 hours, you're going to be pulling the valves out, cleaning them, generally with an ultrasonic method, and then using air pressure at the inlet of the valve to verify that there's no leaking. So this is going to be a clean and leak check. So there's initially an air pressure check. In basically, what you're essentially doing is blowing them out if they had any crud in them, and then a follow-on check at 800 hours to where you're physically removing them, cleaning them, and then pressure testing them as well. Now, the reason I'm harping on these is because someone in their infinite wisdom made the same JIC thread on both the inlet and the outlet fittings. And so these valves can very easily, if you're not familiar with them, be put in backwards. It looks like a number 4 union in some cases. If you look at the different sides on the thread, there is distinct differences in the appearance. One has a conical on one side, the other has kind of a rounded end with like a little screen, a little inlet screen on the other side. But if you're not paying attention, it will thread right up on in there. And now what you've got is basically a constant P3 air leak. Now, in some cases, this may not cause issues with your engine performance because you're bleeding off pneumatic energy. But if both valves were installed backwards, and you had a somewhat older, an aged engine, let's say, running on the ragged edge of performance, and of course non-flat rated applications, which basically are running high power, or right at the power limit of the engine almost all the time, you may notice that your engine's performance is not, sudden power lever splits or staggers, engine low on power to a point where it's now noticeable by the pilots, etc. So that may be a problem. On engines that are flat rated and things like this, we tend to see that the valves themselves go out to usually a flex line or something that attaches it to the overboard drain, a rubber hose or something of this nature. And if you have, and of course, the air coming out of here at this point is going to be several hundred degrees Celsius. And so if it's put in backwards, you may not notice a performance loss, but you may notice that particular engine going through rubber hoses coming from these valves, going through them pretty regularly. They're getting dried out, cracked, or melted, or burnt, or whatever else. So that's one thing to look for. Now, to be sure, there is a wrenching on one of the wrenching flats. There is an arrow, and again, the rule of thumb should always be pointing at the ground. So that would be the normal direction of flow that you would be looking for. All right. Now, setting of your temperature compensator. One of the things that's been added, maybe not necessarily recently, but what had been added is a functional check of the EGT compensator, either at depending upon which engine model you've got and what your phase is, every 150 or 200 hours. And so to functionally check to make sure that the compensator is physically working. Now, when we do this check, okay, and a euphemism, I guess, as I found it with my instructions, is to kind of clarify in orders of accuracy. There's a good way of doing it, and a better way of doing it, and then I think, in my humble opinion, a best way of doing it. But you are going to tailor this to whatever your existing maintenance capabilities are. In some cases, you may not have the equipment, or the aircraft is not in the location to where you have the equipment available for the better or best, and you're basically defaulting onto the good method. Now, the good method, essentially, some aircraft, most aircraft have got a circuit breaker, and the compensator is only compensating when it's powered. So when you turn it off, or if it loses power, you don't lose EGT necessarily in the cockpit, or ITT. You lose the compensation. So you're now going to what would be a raw value. So the value of what's actually being measured at the thermocouple harness on the engine. And so by powering and unpowering the circuit breaker, noting the amount of movement, the difference in the two temperatures, breaker on, breaker off, becomes then whatever your compensator is set for. Now, the reason why this is just good, okay, is when you, and this is just an example of a typical set of 4 gauges. This happens to be for a Metro 26. If you look at the EGT gauge, not all EGT gauges are going to have a digital readout. If it has a digital readout, you are able to do, then the good method can become a viable method and be relatively accurate. Well, the problem you can see here is that on gauges that are only analog, a lot of times you have, at the low end of the scale, these are 50-degree increments. And then you get up in here in this area here to where you're now in 10-degree increments. So if you have small amounts of compensation, say 4 or 5 degrees of compensation, there's going to be no way you're going to be able to see that really with any kind of accuracy. You're going to be wagging it, the needle moving so very little. All right. The other reason why I'm kind of the breaker method is also, in some cases, if you're doing this on an engine that's not running, especially you guys that are operating in very cold environments, regardless of what the temperature inside your hangar or whatever that may be, you may find that at ambient temperature you don't have enough residual EGT indicated. You know, if I had plus 20 degrees of compensation, but my EGT was only indicating 10 degrees of indicated temperature, that's what the temperature around the engine was with the engine shut down, I couldn't use the breaker method and accurately see the total movement of my needle. It would only drop 10 to 0. So in a case like that, it would behoove you would have to put the added step of having to go run the engine just to be able to get enough residual EGT to physically see the movement of your EGT or the effect of your compensator. So that would add, in some cases, an unnecessary step. Now, the better method I tend to find is if you are in possession of a bar field temp tester. The little small bar field temp tester can act like an operating EGT system. It can simulate EGT on an engine that's physically not running. So you can disconnect the thermocouple off the temperature compensator, and you can establish a fixed value of EGT to whatever level you want. And then there adjust the compensator to whatever's necessary to be indicated in the cockpit, to add whatever is necessary to your simulated raw EGT. Now, this method is much more accurate, and it doesn't require the engine to be operated. The only thing I would recommend to you folks on is that if you're going to be doing a bar field test, or use the bar field tester, and you're going to have somebody adjusting the compensator, I recommend you don't use just even numbers on your simulation. All right. For example, let's say I had plus 19 degrees of compensation, and I'm replacing or checking my compensator. What I would do is I would probably dial in something like using my example of my gauge over here, I would probably dial in about try to get something significant. So maybe 220 231 degrees of simulated EGT. Well, then when I dial in or look at my temperature compensator, if I'm doing this as a set point, if I dial in 19 degrees of compensation, the total of raw simulated and compensation would be 250 degrees. And that conforms to one of your marks. So try to use a value of simulated temperature so that when you dial in or set up your temperature compensator, the end result is a more visual indication. You're using one of the marks physically on the cockpit gauge. So hopefully that that benefits you as well. The better method or the best method is to actually set the compensator to the millivolt value for which the value of compensation is equivalent to. Now this is going to be under the engine indicating chapter. This is 7720-03 under the adjustment page block. There is a adjust the temperature compensator, or even, and you can also be using this to check as well. Use method 2. Do not get into method 1. Method 1 uses a piece of equipment that is like a unicorn. In all the years I've been working on the turbine engines now for over 40 years, and I've never ever seen anybody that's ever been in possession of the temperature test kit in method 1. And so most people are using the breaker method. They're using the Barfield temp test method. But in this case, the drawback on this one, you are going to have to develop a small test harness that would allow you then to bench check your temperature compensator rather than just do a breaker pop or something of that nature. Briefly, let's see here. We follow along here. Sorry, folks. Get this out of the way here. Okay. We look at the manual. I'm going to have to do this fairly quick. Down in over here under the adjustment test section, there is a your method 2. If we follow through, and this is the piece of equipment, by the way, that no one seems to have, the unicorn. But method 2, in the manual, there is a conversion of your compensation in degrees Celsius to an equivalent millivolt value. And so what we're going to be using to set up the compensator is not the cockpit gauge, as it would be just a millivolt meter, a standard DVM that has the ability to read millivolts. Again, going to method 2, okay, on this particular application requires you to develop a small test harness that would simulate to the compensator that it's hooked up to an engine. This would be a chrome-L alumel loop on this side, so it fooled into thinking it's hooked up to the engine. And then over on this side would be your bringing in a portable 28-volt power supply simulating aircraft power. And instead of reading out to the cockpit gauge, you're reading out to a millivolt meter. And so with power off, your millivolt meter would be reading 0 millivolts. When you turn the power on, it will then read the millivolt level of what the compensator is physically set for. And so, so you're not having to do any kind of calculation. You're basically dialing in or setting it or verifying in one quick shot, no mathematics involved. Yep, that's what it's supposed to be set for. And if it's not, adjust it until it is. And so I find this to be far more accurate. And this even allows you, in the event of a failure of, say, a compensator, for you to set it at your maintenance location, especially if your aircraft is off-site, and to be able to take the compensator, plug and play. Basically, it's already set and shouldn't be changed, or doesn't need to be changed. And again, with the compensation, we know that this is going to be included here on your data sheet customer. And so your first step whenever you're doing any of these checks is to basically an admin step to go in, verify what the compensation is, and what the current level of compensation is by checking both the data sheet customer as well as your service records in the logbook itself. And so that should always be your first step, is to always be the admin step. All right. Well, folks, that's some recommendations on your temperature compensation. I hope you've enjoyed some of the comments and things and found some of this very helpful. I'd like again to say thank you to Concord Battery for allowing me to participate in this, and I wish you guys all the best of luck with the rest of your seminar. And if you know my contact information, by all means, please, if you're interested in any kind of training or support of that nature, by all means, you have my contact information. I would be more than happy to provide you with whatever you need, pricing, availability, and what is included in the actual training itself. So thank you once again, and I wish you all the best of luck.